Hello, everyone. Thank you for joining this dynamic talk today. My name is Elvina, and I'll be moderator today. Before we start, and before we'll present our speaker, Dmytro, and his presentation about ML AI agents, I want to share some information about our company and why do we organize and why we are sharing our expertise today. So Grid Dynamics is a leading provider of technology consulting, agile, custom software development, and data analytics for Fortune 1000. As here you can see that these are from media, high-tech, manufacturing, healthcare, insurance, finance, and retail sectors. It has been operating since 2006 and is headquartered in California and has development centers in the United States, LATAM, Asia, Eastern and Central Europe. As of today, Grid Dynamics brings together more than 4,500 engineers in 18 countries and continues to grow steadily. Grid Dynamics is a Nasdaq-listed public technology services company with core expertise in big data, data science, machine learning and AI, scalable omnichannel services, DevOps, and cloud enablement. Our company focuses on attracting and developing top talent in the market. The company fosters growth via our internships, university relationships, platforms like Grid University, Skilltree, Grid Labs, and everything is centered around product-oriented delivery. And as part of it, here you're visiting our Dynamic Talks, which is a global event series presented by our company. Here, our experts, leading experts from our company, discusses our technology and digital transformation trends. If you want to see more about our company, to check our job openings, you can check this QR code and our website. And here I want to share some rules about today's talk. During the talk, you can ask questions in the Zoom chat and we will answer them during the Q&A session. Or you can wait and unmute yourself during the Q&A and ask your question by voice. But please be muted and probably I will enable you to unmute during the webinar until the Q&A session to not interrupt other participants and our speaker. The recording of this webinar will be posted on our YouTube channel the next week. And we will share the link via email as the same as a link for this webinar. I think that's it from my side, and I want to present our speaker today. Here is Dmytro Spodarets, our DevOps Architect at Grid Dynamics, with the topic, the operations journey from traditional ML to AI agents, what you need to know about modern MLOps today. Dmytro, as a virtual microphone, and also I'll stop my sharing, so microphone is yours, please.
Yeah, thank you. One moment, I will share the presentation. I hope you see the slide. Yeah. Good. Okay. Yeah, today we will speak about infrastructure for ML and how operations of machine learning models, different type of models, are changing during this period for the last several years. You know, my name is Dmytro Spodarets. I work as DevOps and MLOps Architect at Grid Dynamics. Also, someone know me as a founder of Data Phoenix. I have more than 15 years in tech industry, also built 5 AI and cloud products from scratch to first sales and growing, and also more than 7 years I work as the teacher in university and as well do some courses in AI and data space. So today we can see a lot of solution, a lot of product which use AI. And if we look at mod landscape, we really see very big picture. Several years ago, this landscape have several hundred, I think, 100 solutions. For now, it's more. And all companies which want to use AI, they need to understand the process, how they develop this model, how they operate it, and what they need to do. So today we will look at baseline, what we need to have, and what solution in industry we have for operate models and operate different type of models. Also, we need to understand that ML it's not only only core part of AI solution and AI system. There are a lot of different tools and instrument and system you need to use to build your machine learning system. That's why MLOps is coming to help to do this all in right way, and it combines three core area: DevOps, MLOps, DevOps, machine learning, and data engineering. And today we will see and look at MLOps, LLMOps, and what is going on with AI agent, and is it AI agent ops or it's only DevOps? So let's start from MLOps. The goal for MLOps help companies maximize to help companies to release the product from idea to production solution as soon as possible with minimum risks. And as we speak before, ML it's only one part of big system. So we need to understand the process. We need to understand the core components, and MLOps help us with this. What type of environments we very often work? First of all, it's research environment. Second, it's experimental environment, and third, it's production environment. In research environments, we very often do some test and try to implement some hypotheses which we create or we see in different papers. In experimental environment, we try to, when we find good solution, we try to do some experiment of improving this solution. And the product environment is for run in production. So we do monitoring and get some analytics from our models for improving in the future. And it's three-step, but business want to deliver the solution as soon as possible, and we have different problems can have different problems during all this journey. So is MLOps is the same as DevOps, or it's something different? It's very same, but we have some difference. First of all, we not only do storing the code, but we also store the data. We store some notebooks. We store some environment information about environment. Also, we track the data about training our models. And we work not only standard CPU environment and some small compute, but we work with large GPU systems, and our training can take not 1 hour if we speak about traditional application, which can build several hours, for example. But train models sometimes take weeks or months if you speak about some big models. And we need to understand this, and for this we need to use some different tools, and we will look at which tool set we can use. The ML ops, it's not only the tools or platform. It's more about agreement, how we plan to do ML, and then together with team maintains this agreement. It's very same as in DevOps practice. So main principle for ML, which are staying in the core of MLOps, it's ML should be collaborative. ML should be reproducible. ML should be continuous, and ML should be controlled. For this, we create shared infrastructure. We do versioning, core data, metadata, environments, and so on. We build ML pipelines and do monitoring and validation for our ML models. If we compare also DevOps and MLOps from continuous perspective, in DevOps we have CI/CD. In MLOps we have continuous training, continuous monitoring, which help us automate the process of training and improvement in the future of our models. To know this basis, let's think about what tools and how we can build the infrastructure for our model. As we speak previously, we have 3 different environments, and also we can have as minimum 3 different types of computing resource. It can be cloud, it can be on-premise, and it can be some edge devices. If we look at matching, the research very often we do on-premise resource, because we need to do a lot of experiment, use a lot of GPU power, and it's more easily to buy the cluster for local work and then start to use a cloud. The experimental part, for experimental part, we also can use on-premise cluster, but we start to use cloud for scaling our solution. And the production, we were often deployed to the cloud, or if we need to deploy it to some edge devices. And if we deploy it to the edge, for example, mobile phones or something like that, we need to optimize the model. And it's get for us more specific, more pipelines to optimize the model and use additional tools. If you look at the process of creating models, it's have different stage from collect data, do research, and also do labeling data, versioning data, then to do modeling and training our models, and then store and do versioning these models, and in the end we do serving and do monitoring. So let's create some canvas for select the tools based on which we will plan our infrastructure and tools for our operation models. For my practice, I create something like that canvas, which help me very quickly understand what tools I want to use, and based on these tools create the infrastructure for the models which we operate. Start from part related to the data and the part related to our model and work it in production and other environments. And during this session today, we will see how this canvas is changed when we start speaking about LLMs and what is going on when we speak about AI agents. When we start select the tools and look at what we can do, we have two choices. First, build all using some cloud services, or build some cloud agnostic self-hosted tools, which can give us more more power and be more flexible. So if speak about cloud platform and cloud tools, I can say that all cloud providers today have their own machine learning platform, which cover all core functionality which you need for build your ML platform. Also, there are some big platform, enterprise platform, which also cover all this, all stack, and you can build all in it. But let's see what will be if we speak about self-hosted tools and if we will want to combine, for example, something use in the cloud and to use cloud tools, and from other side to use self-hosted tools to have some flexibility. Okay, my list of the tools which I prefer to use, for example, for labeling data, use Label Studio because it support different type of data, and we can do labeling as for traditional models, computer vision or NLP or time series, or for LLMs, we also can create and label and create data sets for LLMs. For training data, for training models, I prefer use three core tools. First is DStack. DStack help very quickly get access to different clouds and different GPU provider. And it's very easily to run training or run some environment in the cloud or local if you want to work with some Kubernetes cluster, for example. If need to build some environment which will work and use it by different for different tasks, or also automatically scale the resource in the cloud, Ray is very good solution for run training, and not only for run training, also for the inference. And if we need to run large model, which will work and which need a lot of power from GPU, my choice is Slarm as high performance computing scheduler and managed system, which help work with big HPC system. For data versioning, I prefer use DVC, but very often select and build specific solution for the concrete project. For tracking and versioning model, good solution it's MLflow or Wise and Bias. The serving I prefer do in basic line based on fast API and Docker. So create the Docker and deploy the model in the place where I want, or use DStack also or Ray Serve for for deploy the model using these tools. Also, we can use other additional tools like something like what we have in SageMaker in AWS or in Vertex AI, and it depends on the case of the situation of the project. If you speak about monitoring and testing, traditionally, it's possible to build this part using Grafana or Prometheus, but also evidently one of the first, I can say, tools for monitoring and testing very good. And DeepCheck also have open source tools for do testing of the model. For repository and build pipelines and configured the infrastructure. For example, we can use GitHub and GitHub Actions, or we can use GitLab or other Git repository with their own system for build pipelines. Also, it's possible to build some pipeline using this tag because they have very good tools for do some pipeline work. Or you can build pipelines also in MLflow and create the project and create some pipelines there for your train model or version or your deploy model. For infrastructure as a code, it's traditional Terraform or OpenTofu, and for automate the pipelines for this part, I prefer use Scala. So it helps to manage all in better way that, for example, Terraform Cloud provide. So if we take this, we can select some of these tools and build our canvas and see what we have in our infrastructure. But when we try to configure all this stuff in one moment, we will have something like that we have for now and the picture. Very big fire because it's a little hard to configure all and do optimization of all process. So in the industry there are several levels of MLOps. First level, it's when we don't have MLOps, we do all manually. We train model manually, we do deployment manually, we store some code, maybe only Jupyter notebooks, but we don't have some repository. Yes, sometimes we have this one. First level, it's DevOps driven layer when we start to implement some DevOps practice and start to build first our pipelines. Second level, it's when we automate the training and the training start, the process of training start by some triggers. Third level, it's when we automate deployment. Fourth layer, when we get the data from production and have pipelines for automatically create the new data set. And fifth layer, it's fully automated retraining when we get some data from production, for example, have the process of labeling, create the data set, and based on this data set, we have retrained model, and engineers come to some monitoring system. For example, if we store our model in MLflow, we will see the new parameters, new metrics of model, and think about, okay, it's model good, it was improved or not, and so on, and we will deploy it or not. Still, we will go on next, but if you use in your practice MLOps, write in the chat on which level you are for now staying. Interesting to see, and we'll discuss it also in the end, what the level is more popular in the company if you have MLOps in your if you use MLOps. So it was about ML, traditional machine learning models, and when the transformer comes, new era of new type of model are start to growing. And when the ChatGPT was released, we will have the boom of LLMs and same generative AI models. And now let's see what are changing when LLMs come to us. So you know that LLM today use it for different type of applications, start to generate text, create some images, do some work for analyze data, generate code, and so on. But LM have different limitation, and we need to think about how we can improve it. Start from some hallucination, also not sometimes it's not very fast, or the cost is very big. We can have some problems with the token, or LLM don't have last specific information. So we have several variant options how we can improve LLMs. And based on this, also we will build one of or other infrastructure for our model. And for our system, because we need to understand what resource we need, what the tools we need for this, and how we will build all of this. So the easy way is do prompt engineering with context and add some additional context to our prompt. Second, it's build retriever augmented generation RAG system, which will work with some additional information and help us to get more better answer and provide to LM some additional information which LM don't know. Third part, it's do fine tuning of the model. It's more harder. It's more expensive, but sometimes it makes sense to do. And for this, we need more resources. And the maximum expensive work, it's train model from scratch. It's the company do this not very often. They do this if they create some specific architecture or do some improvement in the in architecture of the models, but very often they do more fine-tuning. Also, one of the options how we can improve and do better our infrastructure, it's look not only on large language model, but also look at small language model, which are not so big and not need a lot of power for work. So sometimes it's better and easily take small language model and then improve it and build the infrastructure for it and work with small language models. And regarding use RAG or fine-tuning, my answer it is used together. Because using fine-tuning, you can add to the model some data which will not change it, some historical data which will not change it, but it's not, you don't have reason every time to do some search in this data. It's better to add to the LLM or small LLM, a small language model, and it's also speed up the work and get the result from this data. And for RAG, use some dynamic data which are changed or some new data. For example, it can be first added to the RAG system, and then when we understand that this data will be not changed, and okay, we work with it, we can add it to our fine tuning and add it to our model. Who don't know what is RAG? It's the system where we have several steps of work with data and work with our model. First of all, we have we do preparation and do some vectorizing of our data. So we splitting to the chunk our documents, different type of document, and then to store it in vector database. When we have it in vector database, then we can send some query to this database and do search, vector search, and after get answer, this information will be added to our prompt, which are going to LLM, and then we generate some response and get data. So using this mechanism, we help our LLM to be in the context of the question and of the information with which we work. And there are different paradigms how we can build the RAG system, from standard RAG system which have indexing, retrieval, and generate step, to advanced RAG when we also do some pre-retrieval and post-retrieval operation, and this help us to get more better result and answer. And also we can build modular RAG which can have different models, and using this we can improve some specific model and do our RAG more better. Of course, there are for now more additional type of RAGs. It's, I can say, the basis of how we build RAGs, but in the today there are more bigger list of types of the RAG. So when we look at the list of the tools and what we can need to have in our ecosystem for work with LLMs, for now, this list start growing, and additional to previous MLOps list of the tools, now we have some tools specific to ML models. First of all, we have some open models, or we can work with some providers. Now we have some LLM frameworks, and also we have some vector database and caching, and some specific tools for operating and the model and framework, and also work with prompts, because we need also to understand how our system works with prompts and so on. And of course, we need something related to the security and compliance, because we don't want to have a situation when some private data go out from company, or some from the company have access to some data to which you don't have access. Also, additional to this, some low-code tools are coming, and we can have two ways to use all these components and build our own system, or use low-code tools and very quickly build the solution based on it. And it's really help to do some prototyping very fast. So for now, our canvas are start to be more bigger, and we have very same part in the left for our model, and in the right we have the part for work our solution and our application. And in this part we really have the situation when the model part it's very same to MLOps, and application part it's really DevOps part where we build containers with our application and do some stuff related to this operation. So let's look at what tools we can use for build our LLM solution. First, we need to select some LLM framework, and there are a lot of different frameworks, but the core, I can say three, it's LangChain, LlamaIndex, Haystack. LangChain more focus on connecting different tools and models on himself. LlamaIndex focus more on working with different type of data. So sometimes it's good to combine LangChain, LlamaIndex. LlamaIndex will work with, for example, data, and LangChain will work with other tools which we need. And as I say, components of LangChain and LlamaIndex were the same, but yeah, LangChain have a lot of components which help us work with models, tools, and so on. But it was, I can say, 1 year ago, maybe, or a little more. For now, LangChain it's full ecosystem, which can help you to build a full LLM solution and cover all types which you need, based from create the application to work with different type of model, and to do some tracing and monitoring, and do some observability of your solution. So it's good and help us to more quickly create our solution. But what are the tools we can use for our solution, and what we can select for our canvas? Additional to the tools which we select and work with as with ML model, traditional models. So about vector databases, we can use QDart, Wave8, and for caching, for example, we can use Redis. For monitoring and observability, we can use Arise, FIDER, or we can use OpenTelemetry, because very often more solutions are based on OpenTelemetry, and use Grafana for create our dashboards and do create our dashboards. For prompt management and from prompt engineering, it's very good to use, for example, LangFuse or Prompt Hub or Prompt Layer. They give us good options for manage our prompt, do some experiments with these prompts, and track also metrics. And for example, LangFuse also can help us to do observability. For evaluation and some testing, we can use deep check, Phoenix, or also Vice and Bias and ML Flow start to have the functionality for work with LLMs and do and track the metrics of this type of model. For UI, there are some different solutions which you can use to build your UI interface very quickly and very easily, and which are optimized to work with LLMs. First, it's Streamlit, for example, or Gradio we can use and build on the Gradio, not only the solution for LLM, but also other different tools. As we understand now, we have a second part where our application will live, where we use our LLMs, where we use our LLM framework, for example, LangChain, and we need to somewhere to deploy it, and we can use, for example, Kubernetes and any services for this, or we can use Lambda if it's some specific we need to run some scripts for our LLMs, for example, for do periodic indexing and split to chunks our data and update the vector database, so we can use this. And there are several good low-code tools which you can use for build the prototype play with different type of models. It's, for example, Langflow or Flowwise AI. It's very easily, for example, to see. So you can select some blocks, connect it between each other, and your solution is ready. And sometimes it's enough, because if you don't have large if you need to build the solution for a large company and you want to build for some small company, or you want to build it for your work, you can very easily to create solution and then to deploy it, and you're done. Your, for example, chat is ready and you can chatting with your data. So yeah, if you want to play with LLMs, for example, you can try this solution, and you can connect it for different LLMs providers. So it's very easy. Yeah. Now the result of the stack, what we select, and how all is working with LLM. It's same. We can use Label Studio, DVC for work with data and create our datasets for example, retrain and fine-tuning our LLMs. We can continue track the model, our model, and do versioning on Vice and Bias, for example, and deploy model using Ray. Ray optimized for run LLMs, and also as Ray it's the cluster, so you can deploy model on the cluster and have the number of resources which you need. The monitoring, for example, and observability of your model, which are working, you can do using areas. From other side, we can build and deploy our application which will work with our LLM and which, for example, based on LangChain in Kubernetes cluster, and in this place to create UI, to have some business logic which are on LangChain, have our database using QDart, and we can work with, for example, embedding model from OpenAI for embeddings, for create embeddings of our chunks of which we split it from our documents, and documents can, for example, if we build some part of infrastructure on AWS, it can stay on S3, so we can create some pipelines which periodically update our model, update our data in vector databases. Yeah, and third part, it's agent, and what is it, and how what will be changed in our infrastructure and our process related to agent. Previous year was the boom of I can say single agent. Today the boom of multi-agent system, and we will see growing this interesting solution in coming year. So what are AI agents? If you speak about LLM and work with LLM, so we have some prompt, we have some answer. When we speak about LLM and RAG, we have some prompt, we have some context from our vector database, and we have the answer. When we speak about AI agent, we have the prompt, we have the context, and we have different tools which help us to do some actions based on what we ask the agent to do. So it's autonomous system which can not only give to us answer, but also to do some work for us. There's some number of components which are staying in the agent. First of all, we have resourcing, and we have some instruction for the AI agent. So we have planning and also we can based on prompt split it to task which the agent should do and the role which he will have. Also, agent work with memory and tools, and memory can be short and long term, and tools, it can be different type of tools, start from some specific script to integration with different different services and so on. So as I said, there are two types of AI agents. First, it's single agent, and it's when one agent can do by himself the task. And multi-agent architecture, it's when we have several agents and they connected between each other in different way. And they together do this work which we ask this agent to make. So there are several type of patterns in multi-agent systems. First, it's parallel. When we split it, our job, our task to several parts, and to this agent do this task in parallel. Sequentially, it's when we do in multi-step approach, and step by step, one by one, agent do our job. The loop, it's when the agents start to do some work and then come back to us with the result, but they do and check in the loop the information and the result. Also, the router paradigm, it's when we understand and agent understand in which output which data he should send. Also, aggregator, it's when the AI agent take the data from several sources. Network, when we I can say have decentralized the system, when the agent communicate between each other and then send to us the outcome, some result of their work. And hierarchy paradigm, when we have one core AI agent and he work with different agents for do the work. Also, we have different, as you can see, and as said, we can have different type of communication between AI agents. First type, it can be when the communication and we create all agents in one framework. So then framework do coordination of work with this agent. Second, it's when we use some message queue system, and this is the type when we have the separate agent which communicate between each other using, for example, Kafka. This case can be when we have, for example, different departments. They have their own AI agents, but in some cases, these agents should communicate between each other. So we can build this communication, for example, based on Kafka, or other way, it's API based communication when we concretely know to what agent we want to go, and we have some API there, and we can do communication based on API. Also, one of the way how we can communicate, it's based on shared memory where we store some data in database, in some vector database, for example, and then other agent check it, and if he sees some new information, he start to work based on this new information. So it can be some trigger, or we can say to the agent, oh, I save information in this database, continue work with it, the information on that. And last, very interesting communication, it's when we try to when we build our agent and they work in some simulation environments. It's more related to reinforcement learning when we try to train the agent by himself and to understand how it will go. It's very interesting to look at how this process will go and how they communicate between each other. For example, OpenAI Arena and how they use different agents for playing different games, and how these agents are communicating between each other. Continuing, see what list of the new tools which we can have in our canvas. It will not a lot of new tools are coming. First of all, we will have some list of the framework which can help us to build this agent. And yesterday, OpenAI released agent SDK, and it will be very interesting to see if they kill a lot of other um, solutions which are for now on the market or not. But yeah, we'll see. I'm still not tested, but I hope in coming day to try and build some agent based on OpenAI and can say more about them. So additional to build AI agent, not only if we speak about framework, we need some tools which help us to do to help make some connectivity to some services. We need to have different type of computing resource because AI agents sometimes can have some small scripts which do some work, and it's really easy to manage, like using some lambda and so on. For some cases, we need to have queue system, message queue system. For some cases, we need to have routing, LLM routing, and we can use Unify, for example, for route models and select what best model we can select. Yeah, also the low-code tools which we speak about previously for now help us to build some AI agent very quickly also, and to do some prototyping and understand how it's work and test the hypothesis. But I think, but for some cases it will be enough. But in some cases, after build a prototype, we can go and use some framework and build real code and real application for our agent. So the canvas now a little changed because we have two parts for AI agent. First part, it's work with some type of model, and depend of the structure and what we want to optimize for what we want to do optimization, we can build different structure of our infrastructure, and to have layer where we work with models and layer where we work with our agent. And we need to understand that we need to manage, for example, different type of models and have all infrastructure which we speak previously for traditional models or for LLMs or small language models. From AI agent perspective, it's really DevOps work, because we need to build application using some framework and do some optimization of deployment and communication in the infrastructure. Yeah, we use some vector database. Yeah, we use some memory. We use some prompt management. We use some gateways. We also do monitoring and observability, but it's really same as DevOps. So I don't think that AI agent ops is something what we can call, but LLMOps and MLOps, it's more really what are. And if we speak about AI agent, it's really DevOps work and DevOps side of creating. So today, if you work with AI agent, you need to be good DevOps engineer and also know all about MLOps, because not always you need to have skills to work with models, because you can use some providers and you will not interact with models. But you need to build the agent. Can you build the agent? And if we speak about observability of the agent, we need to track and see. We need to track different metrics. Start from tracking and monitoring our AI agent, then to check and tracking the orchestration of this agent and how they work, and track the performance metric. We need to check and track the security and check the compliance. And what is critical, if you don't want to have the large bill, you need to track some cost of workflows and so on. And also LLM specific observability you need to also do to understand that all your model work correctly or not. Also, if you use API, you also need to understand, maybe you can somehow, if you have some options to improve the model on other side to do this. And the future of AI infrastructure, it's the good topic, and I think it's good part to start discussion. What do you think, where we will come, and what will be next after AI agents, and what will be next in the infrastructure area regarding AI? We can start small discussion and also can start our Q&A session. But let's start to discuss. Maybe someone have some thoughts what AI infrastructure and what AI agent will be in the future.
Thank you, Dmytro. Simon, you can unmute yourself.
All right. Hi, Dmytro. Thanks for the presentation. So one point about the AI infrastructure. First of all, we need to start thinking about payroll for AI agents. Because soon we will be covering a lot of our activities. One thing I wanted to write it in the chat. So for the AI infrastructure, I didn't see in your presentation the agent infrastructure part. So where the agent will be executing, for example, the code, or where the let's say even the accesses are present. So in your case, where do you see this part of the AI infrastructure?
So if we speak about some work of the AI agent, all this part can be done in the, for example, in some Kubernetes cluster where we configure the access for the agent, where we can dynamically run some additional pods and run the code on it, and then close this this type of infrastructure. It's all will be done in the place where and using the tools where the agents are where we deploy it.
Okay, so you're considering mostly the infrastructure where the agent run the same as where the agent is deployed.
Very often yes, but also it depends on the case. For example, if it will work with some external resource, so we can potentially have some agent or some script on that side, and then run there some task and then get back the answer for the some result to our main agent. But yeah, it will be a multi-agent system again, and it's so agent. It's I can say the very good marketing name. Previously, when we have a lot of different specific script which automate some work, we don't name it as agent. It was some script, but they do some same similar. Not always they interact with some machine learning model, but also in some cases they do this. And for example, when I built one of the first company, which name was Fly Elephant, at that time there are no agent at all, but we have some system which automatically can scale and downscale the computer resource in the cloud and understand and do analytics of and do prediction what computer resource we need in what time. But it was some small application with functionality.
Yeah.
But for now,
Yeah.
it's
So like,
yeah,
do you see
agent.
like? So maybe we can wrap it up in the like how we see something in the future that the agent will create his own infrastructure where to run.
Yeah, it's and it's not problem. For now, agent can write for you Terraform or OpenTofu code. Yeah, it can first agent can write the code. Second agent can check this code and do the review. If the review is good, we can pull it in Git repository. And then we can have some pipelines and we can trigger from the agent the deployment and deploy the infrastructure which we need. Then we can have the agent which when he gets the some trigger that all is done with this infrastructure, or something like that that we have some errors, we shut down this infrastructure. Also can use the Terraform and yeah. So it's not very big problem, and I know that if you will look at some solution like Ray, they do some scaling and run and stop the infrastructure, not using the agent. They have their own functionality for this.
Yeah. Yeah, and the last thing that I wanted to ask is any specific reason why you didn't mention in the overall infrastructure the the guardrails part?
Yeah, the guardrails also is a good topic, and I tried to add more information, but the number of slides was very big, so I deleted someone. The guardrails, it's very good topic, and really we need to build and use some tools for check the access, to check the data which are going to LLM, or which LLM are sent as an answer, and also what our agent to do, where he have access, where he don't have access. So yeah, it's good topic to add also to this presentation. But the time.
Yeah, I know.
I try to cover maximum, but yeah.
Yeah, we also tried to cut something at the dry runs. Come on, I think that you understand.
Yeah, definitely. Definitely.
Does anyone hear me perhaps? May I?
Yes, Sergi, I saw that you was unmuted. Do you have a question?
Yeah, for sure. I have a question. Simon, thank you for asking good questions, and that was very valuable to hear. Dmytro, thank you for the lecture. This was like very useful. I'll just ask a couple of specific things because I try to do things in a sandbox in an innovative way. So most of the tools were not really familiar to me, nor do I use them. However, I have devised a logical let's say, workflow for what I'm trying to do with agents, which are not related to controlling other applications, but rather enhancing the results which are deployed through prompting. So I'll just mention what I'm doing at the moment. It's a legal sort of persona, which is for compliance in cryptocurrency and intellectual property, which was assigned a data set, which is approximately 150 pages long. That's an and then that persona has a team of agents which are self-assigning for the most necessitative fields that need to be researched in order to get back with the result. And prior to the results starting, actually the prompt is one of the data sets that is included is VNV, so validation and verification data set, and a separate one is anti-hallucination deceit data set as well. So what I'm just trying to ask with all of this context is basically, is there any particular way I could enhance the delivery from those agents? Because I don't see any faults, but I'm just trying to understand if there is something that's beyond my current understanding which could help me improve the process. Thank you.
I'm not very good understand in which part the problem is. So
Yeah, it's not that much of a problem. It's just me running this by you to make sure, like, I'm not sure if my logic is perhaps flawed and there will be some fault in the process and the delivery will not be really thorough. Maybe one of those agents will not.
do, do you have the trace of all the state of communication between all your agents? So as minimum, you need to configure the tracing and see what answer what answer are going from each agent and what information are going to each agent, and based on this you can somehow optimize, and also you can trace and see the speed of answer, and also think about how to improve the process, how to improve the speed of work. And
I would basically be trying to establish a layer of understanding that would be delivered on top of actually underneath the end result of the query that I'm sending. Because, for example, I'm asking to construct, let's say, a lawsuit or a compliance report for a financial institution, and I do get results that are accurate. However, I thank you for mentioning this. I'm just not kind of clear on how I would be checking how much a specific agent contributed with.
So in this case, I think you need to trace what each agent are great, and then how to compare that. Yeah, it's a good question. Need to check and think. But also to be sure that the answer is good, you can also to do some fine tuning of your model that that to improve the quality of answer for some specific data, and
Okay, cool. Thank you. Just a quick one, really quick one. So if I was to try to detach the process from my own sandbox and have someone else use, let's say, that lawyer and those agents, it would, from what what I've seen in the presentation, it would be really helpful if I was to feed them with a specific data body or a body of knowledge so that the agents would then not be forced to interact with the general LLM, but would have where to pull that from, for example, a set of laws specifically. That would enhance the process, right?
Yeah.
Okay, awesome. Thank you.
Can I have ask a question?
Yes.
I would like to ask about the vector databases. Is there best practice to use Elasticsearch as a vector database for text querying and then making?
I don't have this experience. I don't have this experience, and I think it's better to use some databases and test some vector databases and test the speed for your project, because some work better for some case, some work for other cases. But to use Elasticsearch, no, I don't know. I don't have this experience and don't hear that someone do this.
I might answer that. I
Yeah.
tried.
And
we are
how?
in the same specialization, so I can contribute. I tried. I played a bit with Elasticsearch as a vector DB, and I also tried to see if, for example, with the integration of Solr, make it better for indexing. No, the answer is I didn't have good results compared with, for example, Weaviate or even ChromaDB if you deploy it properly. I didn't have the same results in Elastic.
Thank you, Simon.
Thank you.
Okay, Dmytro, you can decide if you have time to answer the questions in the chat, because we have a lot of them there.
Yeah, you can write me and then I can answer to your question. So feel free to write and I will happy to answer.
Direct.
Yeah, you can write to the email, or if you have some place where we can collaborate, some online chat, I don't know. So we can speak there.
Probably we'll post this video on YouTube and we can chat in comments there.
Yeah.
And share the email, for example. For our Grid Dynamics colleagues, you can find Dmytro in Slack and check all the questions there. So yeah, as we are running out of time, I thank you everyone who joined and for all of these discussions in the chat. I see that someone shared some code, some also comments, and it was really nice to see that. Thank you, Dmytro, for this very big and intense presentation. It was really great. As I said, we will share the recording with everyone, so stay tuned. Thank you.
Yeah, thank you. See you.
Everyone. Dmytro, before we leave, I'll just mention, I just added you on LinkedIn, and I will be definitely shooting you a type of message, kind of inviting you over for a call if you're available in the coming days, as I would definitely use an expert perspective of what I've been doing very intensely for the last year.
Okay.
Cool.
Okay.
Cool. Thank you so much.
Thank you, everyone. Bye.
Bye.
Yeah, bye.